Hi, I am Dr. Saroja, retired professor in chemistry. Today I am going to talk about errors in measurements in chemistry. Measurement is an integral part of our life. It is the foundation of an experiment. We measure usually weight, volume, pressure, height, length, breadth, time and numbers also at some time or the other. Sometimes we fail to measure them correctly, leading to errors. Error in measurement is the difference between the observed value and the true value, and the true value is unobserved value of that variable. Measurement of error causes the recorded value of the variable to be different from the true value. Measurement of an error is the amount of inaccuracy in the measurement. Let's see the types of errors. We should first understand the two basic terms, true value and the measured value. True value is impossible to find by experiment. It may be defined as the average of an infinite number of measured values. Measured value is a single measurement of the object. Errors are of three types: gross errors, random errors and systematic errors. Let's see gross errors. The very word tells us that it is gross. These are large value errors, blunders or mistakes in measurement. This is as a result of the observer's lack of experience, sheer carelessness or carelessness of taking the measurement. These are unacceptable or unpleasant to a great extent. These affect both the precision and accuracy. Example: reading an instrument without setting it up properly, or recording wrong observations like reading 21.5 degrees centigrade instead of 31.5 degrees centigrade without seeing properly, using wrong values in the calculations and the result is wrong. How do we rectify this? By taking a lot of readings, we can reduce the gross errors. The average value reduces the gross error. It can be also avoided by constant vigilance by being extremely careful when we take the measurements. Second type of error is random or accidental error. It's caused by an unknown or unpredictable changes in the experiment. It occurs irregularly due to fluctuations in experimental conditions like fluctuation in temperature or fluctuation in voltage, etc. There is no definite cause that can be traced to this error. Source is unknown and uncontrollable. These are indeterminate. We cannot find out the magnitude of this error. Due to large number of parameters that are beyond the control of the experimenter that may interfere with the result of the experiment, this happens. Repetition of the measurement likely will give different values. Let's see the Gaussian normal distribution of random error. This is the Gaussian curve for the random error. Random error follows normal Gaussian distribution. It has equal positive or negative distribution. M is the mean value or the true value. This is the true value or the mean value. S is the standard deviation. Random error varies from -3s to +3s. It has been found out statistically. Probability of measuring a certain value is on y-axis and measured value is on x-axis, and this is -3s. This is a negative error from the true value, and this is +3s. This is the positive error from the true value. So the random error has both equal positive and negative deviation from the mean, that is the true value. Let's see what is systematic error. These are again of three subtypes. One is environmental error. This occurs due to the effect of external conditions like temperature, pressure, vibration or electrostatic or magnetic field. Observational error occurs due to individual bias. Individuals sometimes they have a feeling that they know the value and they have some bias towards the value. Or due to parallax error, without seeing the reading properly due to incorrect sighting of the measurement, this occurs. Instrumental error. This is again of three different types. One is calibration error. The instrument is not calibrated properly, or mechanical error, or operational error. The experimenter does not operate the machine properly. B. Misuse of instrument or fault of the operator. Zero error. The device is not set to zero properly, or the device is damaged, or the device has a limitation of, let's say, 0.1 mg only it can measure, the smallest unit of measurement, then we cannot measure anything lesser than 0.1. So this also results in the instrumental error. The third type is the loading effect. Voltmeter on a high resistance circuit gives a misleading reading, while on a low resistance it gives the correct reading. Let's see the normal distribution of systematic error. Systematic error shifts up or down the y-axis. The measurement is either smaller or larger than the true value by the same amount, unlike the random errors. Probability of measuring certain value is on y-axis, measured value is on x-axis, and if this is the true value, the systematic error is on the positive side. So it is either on the positive side or on the negative side, unlike the random error. So this is the Gaussian curve of distribution of systematic errors. Let's see how to calculate the error. Let's see first how to calculate absolute error. Let's write this as delta x. This is equal to actual value minus measured value. XA is the actual value, XE is the experimental value. For example, if the actual weight of an object is 35 mg and the measured weight is only 34.16 mg, then the absolute error is equal to 35 minus 34.16, that is equal to 0.84 mg. This is the absolute error. Let's see how to calculate percentage error. Percentage error is equal to XA minus XE, that is absolute error divided by experimental value of the measurement into 100. For this above example, same example, percentage error is equal to absolute error 0.84 divided by XE is the experimental value, that is 34.16 into 100, that is equal to 2.46%. This is the percent error. Now let's see what is relative error. Relative error is equal to absolute error divided by the actual value of the measurement, that is equal to delta x by XA, that is equal to delta x in the above example, it is 0.84 divided by the actual value is 35. So 0.84 by 35 is equal to 0.024. This is the relative error. So like this we can calculate the three types of errors: absolute error, percentage error and relative error. Thank you for a patient hearing, and if you like my video, please subscribe, and next time I'll come up with another interesting topic in chemistry. Thank you so much.